you've got your notes labeled up there, multiplying and dividing rational expressions. We know a rational expression means a fraction. So, what we're going to be dealt here are all different types of polynomials. There could be a monomial, a binomial, a trinomial, and we have to multiply them and divide them. So our plan of attack on stuff like this, and by the way, later we get into adding and subtracting, which this is the case where adding and subtracting is actually more difficult than multiply and divide. Multiply and divide is the easiest. That's why we're starting with it. But anyway, what our plan of attack is going to be is to simplify what we can to get them smaller and then do the multiplication or division. Okay, so that's what we're going to be looking at. And when we do that simplifying, that's going to be some factoring, which those of y'all that are still struggling on factoring are going to have to get with it. Get with it. Okay, so here's numero uno. As soon as my marker catches up there, it's been on break for a few days. I've got x squared minus 4x minus 12 over x squared minus 4. Okay, so let me talk about what we're seeing and then we'll start simplifying it. That big fraction bar means divide. So, you possibly could set this up as a long division problem. That's the most difficult way to do this. I'm not going to do that. I'm not even going to humor that idea. Our plan of attack on all things like this is going to be, if we can break the numerator down, we're going to break it down. If we can break the denominator down, we're going to break it down. Because then if we have something the same on top and bottom, like think about plain old numbers, if you have something like that, that cancels out to just 1. So that's what we're going to be looking for. Can I get a piece here that has the exact same piece on the bottom so that I can cancel it out? Okay? So on the numerator, I'm looking to see what that trinomial factors as. So I'm taking my a times c is negative 12. What multiplies to make negative 12, but adds to make negative 4. Very good, Miss Lane Joe. So I got x minus 6 times x plus 2. Fabuloso. Now on the bottom, the denominator, that's my favorite kind of factoring. It's a special one because this is a perfect square, this is a perfect square, and this is a minus sign. When we did factoring last semester, we called that difference of squares. So you're going to have your 2 parentheses. Square root of the first one goes in both of them. Square root of the last one goes in both of them. One gets a plus sign and one gets a minus sign. Difference of squares. Okay, now here's where the ninja math comes into play. If you have the exact same big chunk on top and bottom, you get to get your ninja sword out and slice them out. It has to be the whole big chunk. Okay, so what I mean by that, I can't say, well, I'm going to mark this x out and that x out. It doesn't work. It's got to be the whole binomial. You can't pick apart binomials. So right now, this is what I always say. What time is it? Ninja time. And all we got left on the numerator is x minus 6, and all we got left on the denominator is x minus 2.
You're so cool. Because you know what? Every time I go to do that, I'm going to go...
Yep, it cracks me up. I like it. The most difficult part, there was not anything too hard for any of us on that, but the most difficult part for some of y'all that still struggle with factoring is going to be that. Breaking those down into those factors. Now, every year on a test, go back to the original problem, I'll see people get it wrong because they try to do this. No, you can't pick apart binomials and trinomials. It's got to be all or nothing. Okay? All or nothing. Let's try another. Let's try another. Let's try another. Show you an easy one. There are some easier ones. Alright, what's so easy about this one?
There's x plus 1 and x plus 1.
It's already factored.
Right. Good, Grant. They've already factored the whole thing. So they've already done the hard work, and Chloe's already got her ninja sword out. Okay, so all you have to do on this one, they've already factored the top. They took a 2 out. They already factored the bottom. So what time is it? Ninja time. All we got left on the top is a 2. And on the bottom, an x plus 3.
Wouldn't, I thought on the bottom you could have a plus and a minus.
No, this x plus 1 times x plus 3 would be the same as x squared plus 4x plus 3. So they've already done that work for you. What multiplies to make 3 but adds to make 4. That could be a positive 3 and a positive 1. Alright. We got what we need on that page?
Yeah. Wait.
Oh, I got you. It's magic. There you go.
Wait.
Is that a 3
Is
or
that
a
2
5?
different problems?
No, somebody asked a question and we discussed it while y'all were talking. If we were to multiply this out, this is what it is.
Oh, okay.
Now we've got x plus 4 over x squared minus 16. Now here's the dilemma that a lot of people run into every time. It's knowing how to start. So if we're given that, the directions will say one of 2 things. It'll either say divide, because that is a division problem, or it'll just say simplify. It could be either way on that. So what would a starting place here be? Okay.
Factor out the bottom.
Okay, Tori and Grant both think the denominator can be factored, and they're right. What about the numerator? Can it be factored? No, x plus 4 is already broken down, so I can't do anything with that. So I'm just going to keep that and x plus 4 on top. How does the denominator factor? Very good. Laney Joe, remember difference of squares. X squared is a perfect square. 16 is a perfect square. So you take the square root of both of them. And one gets a plus sign and one gets a minus sign. Now let me tell you what Riley just noticed. Most of the time, these problems are going to be friendly. If it's telling you to divide or simplify and it's got this on top, you should expect one on bottom. There can be times where something just won't simplify, but most of the time you should look for, if you'd like, I don't know how that factors, well, see if it's got an x plus 4 in it, because that's, the problems are friendlier than y'all think most of the time. So now what time is it? Ninja time. So what's left on your numerator? 1. Good, Laney Joe. And then x minus 4 on the bottom.
I did the.
Yeah, you knew. You just got my word mixed up. I wasn't concerned.
So if it's a perfect square, then you do the different the plus and the minus.
If it's a difference of squares, yes.
Different squares, yes, that's what I'm trying to say.
Alright, how about this one? Directions here say to simplify the rational expression if possible. Simplify the rational expression if possible.
Go x plus 1 in front.
Where are you getting an x plus 1?
Alright,
Okay, remember, for me to simplify, for me to get to use my ninja sword, I got to have a whole thing the same that I can mark out. So on the top, I got a 4. Is there a 4 on the bottom to mark out with that? No. On the bottom, I've got this x. Is there an x on top to mark out with that? No. I got an x plus 2. Is there an x plus 2 on top to mark out with that? No. So I can't simplify that.
So it'd be
It's already in
No
simplest
solution.
form or can't simplify. Already in simplest form or can't simplify. We're not solving anything yet, Grant. That'll be one of the last things we get to. Not even today. Not even today. Alright, before we look at something different, I'm going to let you try one real quick. They got what we need on that page?
Yeah.
Woohoo! X squared minus 2x minus 3 over x squared minus x minus 6. Alright, so your directions say simplify the rational expression if possible. This one is possible to simplify. So what you need to do is factor the top into 2 binomials, factor the bottom into 2 binomials, and then see if you can get your ninja sword out. No. You start whapping Garrett.
No, probably use it actually.
You know that, well, a plastic sword will cut your foot?
I know it's hard enough to hurt if I whack somebody with it.
I know a kid stepped on one and cut his little toe off.
I mean,
It wasn't plastic.
like I heard if I whacked somebody with it.
He just stepped on it.
I don't think I know.
Yeah, I didn't think it either. It actually happened.
Okay, working, factoring. On the top, what multiplies to make -3 but adds to make -2? On the bottom, what multiplies to make -6 but adds to make -1?
I did it. I did it too. I should make a list.
That's what I got. What I got? Yeah, not sit. Not one. Okay, so what'd you get? I got x minus 3 and x plus 6.
You can really cut out either one you want to.
What do you mean?
Yeah,
It's got to be exactly the same.
Oh,
Okay, so what'd you get?
so -3.
I feel like I did it right.
This bottom is right. 6 plus 1 doesn't make -1. Remember, you got to multiply to make -6.
Oh, no, that's a
but-
-6.
Well, that doesn't add to make -1 either. You got to multiply to make -6 and add to make -1. Your B is -1.
So it has to add to be -1, but multiply to be 6. Oh.
-6. It's got to
So it'd
multiply to
be-
be your C and add to be your B.
So -3 and 2. -3 and 2.
Hey, if you're stuck, all I've done on the smart board is factor it. So check and see if your factors are correct.
So you get 1.
C.
X minus 1.
See where we messed up on your factors, possibly, if you were stuck? That factoring's going to get to be a big deal in this unit.
Hopefully I'll be able to factor my numbers.
Okay, once we get it factored, then you start looking to see if you can use your ninja sword, and you can. You got an x minus 3 both on top and bottom, so get your ninja sword out. What time is it? Ninja time. All you got left on the top is an x plus 1, and all you got left on the bottom is an x plus 2. What you got?
When you go to factor a trinomial, doesn't it mean like your B can't be positive and your C can be negative? Did that ever happen?
Yes. So this could have been, that could factor as x plus 3, x minus 1. Right? Yeah. So it's a sign game. You got to finagle and work with the signs on them. Alright, now, all of that stuff was either binomials or trinomials. Let's look at a little bit different take. These are what's considered to be the easier problem, but I always have students that get stuck on this more. This says 8x cubed y, so see that's just a monomial, that's all one term, over 2xy squared. So that's just a monomial, that's all one term because there's no plus or minus signs, times 7x to the 4th y cubed over 4y.
That's a lot of X's and
Yeah.
Y's.
Just the full one.
Okay, now I'm going to show you the first time how to write all this out. But then after that, if you can shorten some steps up and do some things mentally, by all means, you go right for it. But when you've got a multiplication problem with two fractions, which is what we have, forget about the x's and the y's, we're multiplying two fractions, right? All you do on that is multiply straight across the top. So my coefficients straight across the top would be an 8 times 7. Now I'm going to write this out. This is going to be painful. I'm going to write it all out. Times x cubed means x times x times x. I told you a second ago you won't have to write this every time. I'm just trying to show you. Y would be times y. Over here I've already got my 7, but here's another x to the 4th. So 1, 2, 3, 4. And then I got a y cubed. So y. That's all on the top, right? I just wrote it all out. However many, whatever the power was, I wrote it that many times all the way across. So on the bottom, I got a 2 times a 4, my 2 and my 4. Then I got an x. This is y squared, so that means y times y. And then over here with the 4, there's a y, so that's another y. Okay, but now what we'll be able to see, well, we could, but the reason I wrote them out this way is because what we'll be able to see, if there's an x on the top, I can mark it out with an x on the bottom. If there's a y on the top, I can mark it out with a y on the bottom. So here I've got an x, here I got an x. Okay, now are there any more x's on the bottom? So I can't mark out any more of these x's on the top. So let's count and see how many of them we got. 1, 2, 3, 4, 5, 6. So that means my answer is going to have an x to the 6th, isn't it? Are you okay on that?
Yep.
Okay. So now here's a y. 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 Any more y's that I can mark out? I've still got one on top, but there's not one on bottom to cancel it out. So that means my answer is going to have a y on the top. Y is the y on the top because that's where it was left over at. Okay, if it had been left over on the bottom, we would put it on the bottom.
So there's X on the top.
Because that's where they were all left over at, was on the top. So our variable answer is going to be x to the 6th y. Okay, but now we hadn't done anything with this. Well, look down here. What's 2 times 4?
8.
Right?
So it's just 7.
So all we got left is that 7, and it's on the top, so it goes on top with my x and my y.
What? That was crazy.
Now, using your exponent rules, could I have done that using the exponent rules without writing all that out?
Definitely.
Exponents, when it's a multiplication, gets added, right? So 3 and 4 makes 7. So I've got x to the 7th on top, but I got an x on bottom. Top and bottom means subtract. 7 minus 1.
6.
Very good. Okay, y and y to the 3rd is y to the 4th. Down here, 2
you
and
have
1 is
3
3rd. So 4 minus
it would
3.
just be 1 y.
Just be 1. So Chloe's going to get there a lot faster than writing all this out, and that's fabuloso.
What happens if you have... Oh, wait, never mind.
What?
It processed in my brain.
Okay. Glad I could help. All right, let's put that together now with some binomials and trinomials. Woo-hoo! Alright, so on the left side, we got 3x minus 3x squared. Excuse me. On the right, or on the denominator, x squared plus 4x minus 5. Then over on the right, we got x squared plus x minus 20, and then just 3x. So we did a problem when we started off here. We did problems where we had that just on one side. Now we've added another side to it. So it's still going to be the same. We're going to simplify every piece that we can, and then we can ninja math across that multiplication sign. So that's what we're going to look at here. So on the top left, 3x minus 3x squared. How did that factor? Can I simplify that? You can take a 3 out and an x. So that's got a GCF of 3x. So I'm going to go to red here. So I'm going to take a 3x out of this top left. So it was a 3x. I divided it by itself. That means there's a 1 left, right? Bring down my minus sign. It was a 3x squared. I took a 3x out. So there's just an x left. GCF is always solved.
Attention all juniors. Tomorrow you will be taking the ACT from 8 to 11:55. Please make sure that you bring your Harmony Grove student ID, your fully charged Chromebook, appropriate calculator, and pencils.
On the bottom, x squared plus 4x minus 5. That's a trinomial. There's not a GCF, so you're looking for what multiplies that makes -5, but adds to make 4. So x plus 5 times x minus 1. Okay, I've simplified, I've factored, I've broken apart everything on the left side. Let's jump over to the right. There's no GCF, it's a trinomial, so what multiplies to make -20, but adds to make +1? Close.
-5.
-4 and +5. My 1 is positive, so I need my bigger one to be positive. So the 5 will be positive, and now there's a hint. You had a +5 down here, right? And then x minus 4. Okay, on the bottom, all we got is 3x. You can't break that down. All right, so now you've broken everything down. So if you've got anything that you see that you can get your ninja sword after, you can go ahead and do that.
You can get 3x and x plus 5. And x
Okay,
minus 1.
now pause. All those things that Grant just ninja'd out are correct. And Grant and Laney Joe are onto something here, but it's fishy. Okay? They do look similar, but this one's got a +1 and this one's got a -1. This one's got a -x and this one's got a +x. So they're not exactly the same, but they are exactly opposites, aren't they? So wouldn't, if I multiplied this one by -1, wouldn't that make it be this one? So I can take a -1, I can take a -1 out of that. -1 divided by 1 is -1, which is what this one is. Follow that? -1 divided by -x, plus use a +x, which is what that one is. So now, so all we got left on the top is a -1 and an x minus 4.
So your -1 is on top of it.
And on bottom, we don't got anything left. All right, so choices for writing our answer. Some of us might circle that. That is a correct answer. What if that's not a choice on the ACT? Could put it over 1. What else?
You could solve it out.
You could distribute that -1. That'd make it a -x plus 4. That's the same thing. So either one of those would work. Good? Everybody okay on that? That -1 trick is tricky. When they're exactly the opposite signs, you can always take a -1 out. That doesn't come up extremely often, but you will see it from time to time. All right, check this out. Everybody got what we need on that page? We got x plus 2 over x cubed minus 27 times this whole trinomial of x squared plus 3x plus 9. All right, what we got going here?
Isn't 27 perfect cube?
So Laney Joe notices that x cubed is a perfect cube because x times x times x. 27 is a perfect cube because 3 times 3 times 3. So this factors as a difference of cubes, which most people, it's not used as often, so most people forget it. You might have to go back to last unit and dig out some factoring notes. On this left top numerator, I'm going to keep x plus 2 as it is. Difference of cubes factors as take the cube root of the first term minus the cube root of the second term times, now you square this one, plus you multiply them, plus you square the last one. 3 squared is 9. Yeah, you take the cube root of the first term, cube root of x cubed is x, cube root of 27, the cube root of the second term is 3. Then you fill in your trinomial by squaring the first one, multiplying the two terms, and then squaring the last one. Now, what does that let you do? Can I cancel? Can I get my ninja sword out after a whole trinomial? As long as it's exactly the same, or my trinomial is exactly the same. X squared, 3x, 3x, 9, 9. Whoa, that was some kind of ninja sword there. So all we got left on our numerator is x plus 2. On our denominator, x minus 3 times 1. Now, y'all are starting to get to figure stuff out, how math things try to trick you. It looked like it was going to be complicated with that difference of cubes, but most of the time, if you've got a sum or a difference of cubes, it's going to cancel out with the other trinomial. Things always work out like that. Y'all think, oh crap, this is going to be so hard, but they gave you easy, friendly things to get to use your ninja sword on. Alright, got what we need on that page? There's a lot to look at with this ninja math. Ninja math. 7x divided over 2x minus 10, or divided by, I started to say. Now, check this out. Divided by x squared minus 6x over x squared minus 11x plus 30. Okay, all of them so far have had a multiplication sign between them. This time I put a division sign between them. But I would say to you smarticle people that you already know how to do it. Because what does division with fractions mean? Bless you. Multiply what? Kind of, sort of, but I can't say that. The what?
Straight across.
No. Division of fractions means you multiply the, starts with an R. Reciprocal, very good. So I changed that division sign to multiplication sign. Reciprocal means I flip it, and it's the exact same type of problem we've been doing. So this is the same, Riley, as 7x over 2x minus 10 times the reciprocal. X squared minus 11x plus 30 over x squared minus 6x. So now it's the same. We don't have to learn anything new. We're going to break down everything that can be broken down and then see if we can get our ninja sword after anything. So on the left, 7x. Does that break down? No, it's just plain old 7x, so I'm going to leave that. What about 2x minus 10? Take a 2 out. Leaves you with an x minus 5. Okay. Most of the time, if it's not a difference of squares, you're going to take a GCF out. Here we got a trinomial. Close. 7 times 5 doesn't make 30. You were close. What multiplies to make 30 and adds to make negative 11? Yep. An x minus 5 and an x minus 6. And you had a good idea. Look over here on the bottom left where my mouse is going crazy. You had a good idea to try negative 5, right? Okay, what about here? How does x squared minus 6x factor? Take a GCF of x out. That'll leave you with x minus 6. We've broken everything down. We've taken our bike apart and laid it out on the carport floor. Get your ninja sword out. And now I've got one more thing I hadn't cut yet that I can cut.
You can take an x out of the
Very
7.
good. I told you earlier you can't pick apart a binomial. That means a two-termer. You can't take an x or a 5. It's got to be the whole thing. But a monomial, you can pick on a monomial. So all I got left on the numerator is a 7. All I got left on the denominator is a 2. So all of those variables gone. You just got 7 halves or 3 1/2 if you want to write it that way. He gone. He gone. He gone. Alright, let me find a good one for you to try to sum it up. Where's that page that I have? There it is. Alright, try. I'm going to write it for you and you're going to try this one in your notes. That's hard. Let's do that. 9x minus 9x squared over x squared plus 7x minus 8 times x squared plus 6x minus 16 over 9x. Alright, see if you can simplify that.
It's a little hot in here, Coach.
It is, it is, it is. I concur.
You should get a fan since you can't control your own.
Yeah.
It's on this.
Mostly, the fraction operation will be different, but what Ms. Withers doesn't want us to tell y'all is that our calculators will be down there and check out. Yeah, they'll be down there and you'll check it out. But the reason we're not telling y'all that is because at some point when you start taking it on a Saturday, you need to get one, because we can't do that. Yeah, the only thing I think it doesn't do is the fraction shortcut. Alpha y equals, they don't have that. So you would have to put your fraction in as a division problem in parentheses. Like if it said, if you had to put a half in, you would just have, on those you have to do is like these people did, negative 1 divided by 2. So that's.
Well, my grandma's doing it for 3.
That's yeah, yeah.
Not text her.
Yeah. Everybody got them broken down? That's your first step.
I have them written down.
Well, you better put your factoring pen working, you little
I'm sorry,
toot.
I have a headache and
That's
I'm like,
unfortunate.
it is unfortunate. Thank you for understanding.
No, I called you a toot. Listen up, maybe you'll hear what I call you. You non-listening toot. I'm on a roll.
Calm me out. It's fine. I know you love me. Don't even pretend you don't.
No, I'm not. But you're still a non-listening toot. Alright, I've done most, keyword being most, of the factoring. There's one trick on there we'll talk about in a minute. It has to do with the problem we did earlier. So everybody look at their factors and figure out where all that came from.
I see what you're saying.
That's what mine says.
Yeah. What x squared? What you talking about, Willis? What you started is right. X plus 8, x plus 8. Then you can do the 9x's. Now the only thing left is we're going to talk about those are opposites, so we can take a negative 1. Yes. No, because you can't pick apart a binomial and trinomial. But I don't have, the only monomial I have is that 9x. We're going to chill track here. This is a monomial because there's no plus or minus sign in it. Alright, most everybody has got the factoring ready, and Bella's already got her ninja sort out, so I'm going to get caught up with her. Okay? Then, from there, and Bella noticed it as well, those are opposites, right? Because this one's a positive 1 and that's a negative 1. This is a negative x and that's a positive x. So just like on that one that we had earlier, when you've got opposites, you can take a negative 1 out. That'll make that a negative 1 and a positive x, which is the same. So all we have left on top is a negative 1, and over here, an x minus 2. On the bottom, you got nothing left. If this is one of our normal type tests and you've got a blank, you can write that. That's acceptable. You could also write that. Distribute the negative 1. That's acceptable. Every now and then I'll see somebody write 2 minus x. Is that the same thing? Yeah? It's weird to me that you wrote it that way, but it's the same thing. So all of those would be acceptable answers on that. Alright? Okay, let me tell you a little bit about where we're headed with all of this tomorrow. Junior's taking the ACT, and I'm not in the big room. I've got a small group that I'm giving it to, but for those non-junior people, the reason I'm saying that is because I'll be with ACT somewhere also. So I think they're supposed to have subs. I'm not real sure. Sometimes they send people to different rooms to try to consolidate the number of subs. I don't know how that's working for sure. But anyway, we're not doing anything tomorrow. So then that's Wednesday. Thursday, listen real quick. Thursday, we're going to go on to the next unit in this, which is where we start having something that looks like this, but instead of a multiplication sign, it's got a big addition or subtraction sign. Now, that's where this can get a little bit more complicated, because in order to add or subtract fractions, what do you have to have? I'm talking, Hunter. In order to add or subtract fractions, what do you have to have? Same thing you had to have in the 4th grade when you added or subtracted fractions. What has to be there for you to be able to add and subtract fractions? Common denominator. Very good, Michaela, and that's where you were going, Grant. And so sometimes this gets a little involved trying to find that common denominator. Gets a little bit more tricky. Still going to attack it by factoring and that type of stuff, but that's where we're headed. And then the last, after we learned to add them, subtract them, is what Grant was talking about earlier. Then they're going to become equations. So we'll have to start solving them. Okay? We are going to have some practice on some of this stuff scattered in next week. Some assignments and stuff for you to get some good practice on. So be expecting all that stuff. Everybody good?